Okay, here we go. So today we're going to take notes on fibers and textiles, which are quite similar to hair. So some of this will sound familiar. Okay, introductions. There you go, Kevin. I thought you would like this guy. Holding the sign that says fibers. So fibers are used in forensic science basically to create a link between a crime and a suspect. We know through Lockhardt's principle of exchange that through normal activities, we shed fibers and we pick them up throughout the day. Finally, fibers are classified as trace evidence. All right. I want to show you this image because this is what you would see if you looked at some fibers underneath the microscope. If you look up in the right-hand corner where the blue arrow is pointing, that is a cross-section of wool if you were to look at it under the microscope. As you can see, wool has diagonal lines that intersect one another, and it almost looks like a braid. In the bottom left-hand corner is an example of cotton. Okay, cotton is a very common fiber, and if you look at it, you can tell it's almost rope-like, right? It looks twisted. And finally, if you were to look at hemp underneath the microscope, you would see that it is very flat and much wider with vertical lines, many different vertical lines running through it. So these are 3 different types of fiber, and they all have very distinctive characteristics about them. Okay, how do we use fibers? Forensic scientists use fibers to look at under the microscope. The reason they look at them under the microscopes is because you can distinguish the type of fiber you're looking at, the color, the possibility of violence if inflicted, the location potentially of suspects, and a point of origin. If you look at the 3 examples on the right-hand side, those are different fibers: polypropylene on the left, nylon in the middle, and polyester on the right. Those are magnified images, and they look very different. Just like hair, fibers have unique characteristics that can distinguish them and categorize them. Okay, how do forensic scientists obtain or get fibers? There's a couple different ways. The first is literally a special vacuum, and what it does is at a crime scene, it sucks up different fibers, and then you can go into the receiving little basket and take them out from the vacuum. You can also use sticky tape, and just what you're thinking, the sticky tape would go around and you would use it in order to collect different fibers that would adhere to the sticky side. Similarly to sticky tape are lint rollers. A lot of people have these in their homes in order to take off dog and cat hair because what they do is literally they just get the fiber to stick to the tape. And finally, you can use forceps, right? Or another word for forceps is tweezers. Okay, there are a couple different methods in which scientists use to analyze fibers. The 2 basic ones are, one is when scientists look at the fibers without damaging them. You can look at fibers without damaging them through microscopes, right? And that will reveal characteristic shapes and markings of the fibers. You can also look at fibers without damaging them when using infrared spectroscopy. And what this does is it illuminates the chemical structures of the fibers to differentiate what fiber you are looking at. And basically you're bouncing light waves at them. Okay, the other method of looking at fibers are destructive methods, and those are either burning fibers and or dissolving them in different liquids such as acid. Okay, and again, these methods, similar to the non-damaging methods, provide distinct information which can then be characterized and categorized to discern what type of fiber you are looking at. Okay. How are fibers classified? Fibers are classified in 2 different ways. They are either natural, meaning they come from animals, plants, or minerals, or they are synthetic. And all synthetic means is that it is man-made. So you see on the left, you see a very woolly sheep, or on the right-hand side, you see a synthetic or a man-made yarn. All right, so let's dig deeper into synthetic versus natural, and let's figure out how do we tell the difference between the two. Okay, you can use a microscope, which will look at the color, diameter, cross-section, and or the striations or the stripes of a fiber. You guys think about looking at the hair underneath the microscopes. We were able to look at the color, diameter, we were able to look at the medulla, we were able to look at many different things, and very similarly, you can do that with fibers. Okay, we know that synthetic fibers have very smooth surfaces. They have a very uniform size and shape. Remember, that's just synthetic. That's just man-made fibers. If you look at the image below, these are all man-made fibers, okay? They can either be very uniformly round, they can be trilobal, meaning they've got 3 different lobes. The fiber could be very flat, or it could be in the shape of a dumbbell. Now remember, these are man-made fibers. Natural fibers, because they're natural, they have more variation in their surfaces, size, and shape. Okay, how can we tell the difference between synthetic and natural fibers? Couple of things. You can look at the chemical composition of the man-made fibers. Because they are made in labs, you can use IR spectroscopy or infrared spectroscopy, and basically all that is, you guys, is bouncing a lot of light waves at the fiber, and then the fiber is going to send a light wave back, and it tells us kind of what's going on and what kind of fiber it is. That's one way. You can also extract the dye and the colors from the fiber, which then separate themselves and actually reveal what kind of synthetic fiber it is. If you take a look below on the left-hand side, you will see that there's a fiber sample, okay, and the dyes, what's happening is that the dyes are moving up and they are separating themselves on the litmus paper, okay? And on the right-hand side, that litmus paper is being reviewed, and it's being looked at and examined to determine what the different layers are and what are the different characteristics, which can then be turned into what is the type of fiber you are looking at. Okay, so you could be looking at a natural yellow, a natural brown, all different kinds of information can be gleaned or taken from just the dyes that are extracted. All right, let's talk about natural fibers. Okay, one source of natural fibers comes from animal fibers. These fibers are made of proteins, and you can find them from wool and cashmere, which come from sheep. You can get it from mohair, which come from goats, angora, which come from rabbits, hair, which comes from alpacas, llamas, and camels, or you can even use silk, which comes from caterpillar cocoons. Again, these are all natural animal fibers. These fibers are made of proteins. Now, you can also have plant fibers, which are considered natural fibers, but these are not made of proteins like animal fibers are. These are made of cellulose, which is fat. Okay, plant fibers are unique in that they absorb water. Okay, they do not break down. They are not insoluble in water. They're super resistant to damage from harsh chemicals. They are dissolvable by strong acids, and they do become brittle, over time. Okay, in addition, plant fibers, we generally think of examples like cotton. It's the most common textile plant fiber. Okay, there it is on the plant. We also think of coconuts, which is super durable. There's an example below. And then another natural fiber is either hemp, jute, or flax from stems, and these grow in bundles. And there's an example of, under the microscope, the bundle-like stems. All right, so we're done with natural fibers. We're going to now talk about synthetic or man-made fibers. Okay, 50% of all fabrics are artificially or man-made. Some examples include rayon, acetate, nylon, acrylic, and polyester. And we're going to take a look at some of these specific ones. Okay, I want to talk about synthetic polymer fibers. These are a petroleum or an oil-based fiber. They are very, very different from other fibers. These fibers are spun together into yarns, and there is no internal structure. Because this is synthetic or man-made, it does not have an organic internal structure. But they do have very uniform diameters. Remember, these are all made in the lab, so they can make them precisely and exactly the same, unlike in nature. All right, so basic example that we can think of a synthetic fiber is polyester. Another word for polyester is fleece, right? We know it is super wrinkle resistant. It is not easily broken down by light or acid. And sometimes polyester is added to natural fibers such as wool to provide strength. Okay, another example of synthetic fiber is nylon. Now, unlike polyester, nylon is easily broken down by light and concentrated acid. But other than that, it is similar to polyester, right? Nylon can be added to other natural fibers for strength, and it is definitely wrinkle resistant. Okay, the last two synthetic fibers are acrylic, which is super inexpensive. It does ball up easily, as you can see in that image below, and it's a really good substitute for wool or fur. And finally, a lot of athletes use olefins, and this is high-performing fiber. It's quick drying, so it wicks away moisture, like Under Armour, and it is definitely very resistant to wear. All right, let's summarize what we have learned today. All right, we know that fibers are a form of class evidence. We know that fibers are a form of trace evidence. So we can narrow fibers down to either being synthetic or natural, right? And we can narrow them down even more to being an animal or a plant natural fiber, or it could be in the class of polyester or nylon, but other than that, they are not individual evidence. Okay, we know that fibers are spun into yarns that have really specific characteristics that we can look for underneath the microscope in order to identify them. Yarns are woven with different patterns and then into clothing and textiles. Fiber evidence is gathered using different techniques, right? Going back to those four techniques such as the vacuum, sticky tape, the lint roller, and the forceps. Okay, fibers are analyzed using burn tests for solubility in different solutions, polarized light microscopy, or infrared spectroscopy. Remember, you can look at synthetic fibers or any fibers using either damaging or non-damaging methods. Damaging means that the fiber will be damaged after you have tested it, but you will be able to collect results. Non-damaging methods just means that you're going to be looking at them under the microscope or using infrared spectroscopy. Okay, fibers are classified as either natural or synthetic. We identified that natural fiber sources include animal hair, plant seeds, fruit, stems, or leaves, and or minerals.